What is Elixir? What is your elevator pitch?
Elixir is a dynamic functional programming language. It's important to note that because it's a wrapper language around Erlang, you get all of the wonderful, amazing things that Erlang provides with the quality of life and modern features.
When they were originally architecting the language back in the 80s, they expected this to be running on telephone boxes out in the middle of nowhere. They didn't know what kind of conditions the hardware would be in. But when you think about designing a language around that concept, that's the absolute perfect use case for embedded device. So the whole reductions concept, let's say they're processing some really heavy data or something, and you start to see the CPU spike on it. So the VM is very good at determining which of those processes are taking up a lot of resources, and then it will properly quarantine them in such a way that it could still give appropriate resources to those other processes while still having the hefty one run. Today we are talking about IoT in Elixir. If you're a CTO looking to get into the space, or maybe you're just curious to check out like what is Elixir, how does it work with embedded devices and everything, come to the right place. So I'm Henry and I'm joined with Tyler, and we're here to learn you IoT and Elixir. So let's get in to start a little bit. Tyler, what is Elixir? What is your elevator pitch?
Elixir is a dynamic functional programming language. It's actually a wrapper language around Erlang, which you might or might not have heard about. It's very, very popular in the telecom space. Erlang itself never really rose to general popularity, but Elixir is a more modern syntax, pleasant way to work with that language. It's important to note that because it's a wrapper language around Erlang, you get all of the wonderful, amazing things that Erlang provides with the quality of life and modern features that Elixir does give to our programmers. Primarily, some quick bullets on it. The primary features that Elixir really prides itself on that are relevant to IoT are things like concurrency and scalability. This is all written on the Erlang virtual machine. I'm not really going to get into the weeds on what that means, but that Erlang virtual machine is really well known for handling massive amounts of concurrency. It scales very effectively. Fault tolerance is a primary feature of this ecosystem, so it makes it particularly good for things like IoT, where you can't really afford for your devices to fail. They need to be able to recover. Very robust ecosystem, great tooling. The developer quality of life is, very, very high, robust documentation. And it's first and foremost, it is a functional programming language. So it's very easy to get into and write effective code quickly.
Yeah, I'm trying to remember what was it that Erlang and Elixir was the first language to reach 9 nines of uptime
Yeah.
or
So I
something
mean,
like
it's
that. So it's milliseconds a year of downtime.
with the language, like the Erlang and Elixir by extension, and just so we don't keep repeating the same points, everything that Erlang claims from, it's all of its positive notes, it's the uptime, reliability, all those things. Elixir is giving those by extension. It's a language around a language, a way of making it more approachable and easier to work with. But yeah, the Erlang got its start in telecom, where critical infrastructure is, it has to stay up. If you can't afford for 911 to work, you can't afford for your telecom switches to work. So reliability is at its core. So if that's something that's important to you, it's definitely, you're in the right place for that.
Yeah, no, absolutely. There is, so a lot of people do ask, like, because you have a lot of languages to pick from when it comes to embedded systems and everything. And I know like C++ and Rust are pretty common. Any thoughts on it? Because I'm an Elixir fanboy. So like from a pure syntax standpoint, like it is one of the best ways to go about it. But
It's a bit of a tough sell, right? Because you don't want to alienate anybody else who has particular preference. Like with most things in technology, it's the right tool for the job. Elixir, Erlang have certain things that differentiate them. C is going to be, is very dominant in the embedded system space in IoT because you get a lot of control over what you build. Python, very popular because it's just prolific. It's easy to get into, a very large ecosystem. Java, been around forever. Lots of Java devs. It's also built on a virtual machine for portability. Like gives that same benefit, also being a virtual machine language. Go, probably Elixir's greatest competitor. also a great choice from an efficiency and tolerance standpoint. And Rust is also gaining traction in IoT because you get the memory safety and garbage collection without it being really really heavy. All these languages have great strong points. Kind of recapping back to what I touched on earlier, though, Elixir's main thing: fault tolerance and concurrency and scalability. With embedded systems, if the stability and the safety of the thing that you're making is really important, that's something where this language really, really differentiates itself. And it's something that you can really stand behind, mainly because it has a very, very long self-tested history. You can get in front of, your other executives, your peers, and be able to really cite a long and very, well decorated history of success and stability in this space. And and especially with technology and emerging technologies, that's not always something that you can do, especially when you're risking for newer techs that you might be adopting and bringing into your ecosystem. When it's new, it's also you get all of that stability from the. So that's definitely when I think of IoT and what makes Elixir, what makes it competitive against the other languages, the stability and the concurrency are what immediately jump out.
Yeah, there was, because I remember a metric somewhere that I think it was Motorola saw like a 4 to 20 times code reduction when they switched from C++ to Elixir. And I was trying to figure out like what was the thing behind that. And so it actually, what I didn't realize, so within Elixir and Erlang, they have the system called OTP, the Open Telecom Platform, but all of that is so baked into the core language that when you use a language like C++, you have to write all of that yourself, basically. So it's kind of wild to me to realize that, like, hey, they were able to drastically shrink their code bases just by switching to Erlang and Elixir. It's wild stuff. And I do wonder about that for other languages in general, because if C++, if you're writing all of that stability and reliability code on your own, imagine how many different flavors are running out in the wild. And it seems like such a natural choice, to pick Erlang and Elixir and the OTP framework by extension.
I mean, that's a
Yeah.
really good point. That's kind of what I was touching on earlier, that the ability to say that there is a long history of that stability. OTP is the secret sauce to that stability. I mean, you have an immense, well documented, battle tested set of libraries and tooling for yourself, your team, your developers to pull on to be able to build these systems. And they don't have to be experts. These even novices can use these systems to create, enterprise grade solutions with that reliability. But that's a really great transition kind of into like the history of Elixir and how it weaves itself in with IoT. So I mean, why don't you tell us a little bit more about why Elixir and IoT kind of go together here?
Yeah, no, that's fair. This is kind of funny to me. So 90% of all internet traffic basically flows through the Erlang Elixir VM. There's so many, like, you got to throw so many words behind it, but let's just calling it Elixir for now. So effectively 90% of internet traffic flows through Elixir type network routers and switches. When you kind of think about it, it's almost like Elixir and Erlang have been IoT before even IoT became a thing. So you can imagine like the internet itself is already running on this language. And then the internet further grows and you have embedded devices everywhere that are also connected. Like it just seems like such a logical fit for a lot of things. And it's kind of funny too, when they were originally architecting the language back in the 80s, putting Erlang together for the Open Telecom platform, they expected this to be running on telephone boxes out in the middle of nowhere. Like there may not be or consistent power to the device. I don't know, a bear might attack it. Like it literally, like they didn't know what kind of conditions the hardware would be in. But when you think about designing a language around that concept, that's the absolute perfect use case for embedded devices, because they could be anywhere doing anything. You don't know what's going to happen. But what you want is a reliable system that can connect as long as the internet's available and do what it needs to. So yeah, it seems like such a natural fit to me.
Put a little bit of color though on the 90% of traffic through Erlang Elixir, the network switches. So like the
Yeah.
things, the data that flows through the internet, that's primarily, and that all comes back to my earlier point about telecom. right? That's where this ecosystem started, and it's where its roots are. So it kind of makes sense that it touches a little bit everything as data flows through the internet. And I definitely agree with your point about that. It kind of feels like IoT before IoT. A lot of the concepts, the common problems, and the patterns that what we consider IoT as a field today face, these were all problems that had to be thought about and solved within Erlang for the OTP library. So yeah, it's interesting to kind of think that these are all new or non current era problems, but a lot of this has been thought about and solutioned in the past.
It's nothing's ever new. We just rehash the same stuff
Yeah.
over and over again.
Well, I mean, that depends a lot on technology, right?
Yeah.
Over the abstractions later, we think that we're, doing something new, and then we find out that somebody did it 10 years ago, kind of feeling. But
Yeah, absolutely.
But I think it's useful for us to talk about, some of the maybe successful IoT projects that use Elixir to give a little bit more credibility. And like, yes, there are companies, there are businesses that have leveraged this in the field. One of my personal favorites, I'm really into gardening. I love plants. It gives some relief to the nitty gritty technology day in, day out. There's Codedge robots, which does a full in the field automated planting harvesting system. It's really neat. If you've never seen it before, you can actually like install this, scaffolded machine over your planters, and then the whole thing can be planned with software for you to plant crops, harvest crops. It's really neat, and all Elixir is behind empowering all of the in the field systems for that. So there are definitely examples of projects that have successful projects Elixir has helped succeed. I think Henry's got some other examples as well.
Yeah, it's pretty wild about robots. Something that I guess comes to mind for me, and I'd heard this a while ago, but basically, so Nintendo Switches, for their notification platform, they basically custom wrote a system that uses the Erlang virtual machine in Elixir. Basically, it was all custom done, and they could manage 10 million simultaneous connections for Nintendo Switches connecting to the remote backend servers. So it would maintain a consistent connection that could display the push notification and do all that. But they were processing like upwards of 2 billion messages a day. Like, wow. And that's something too that, like, I guess it's easy to think like, oh, just Elixir for the IoT device itself. But really at the same time too, it can be Elixir for the backend servers. It can be Elixir all the way down if you want it to. Because like we were saying, it's really just the internet, or IoT is just an extension of the internet. Like, why not keep using the same technology over and over again and harness all those benefits at every layer? Yeah.
Yeah, a lot of the things that make Elixir competitive as a language and a good fit for IoT at the actual low-level device level, that the concurrency and the stability, they're appealing to backend systems as well. You want your enterprise servers to be able to run efficiently. You want them to be able to handle high load. So yeah, I mean, although 2 billion messages per day, I mean, that's pretty good metrics that they're handling there, and that's a complete Erlang based message broker is what was being described earlier. So I mean, Nintendo can do it for a big system like that. It's pretty impressive.
Yeah.
Proof of concept.
It's a shame. It's a shame they didn't use my push notification library, though. It would have been nice, but I don't know.
Yeah.
Props to them, though, in custom rolling a solution.
Sure.
Yeah.
Well, I think we've talked a lot about the history, what makes it interesting. I think it'd be useful for us to see maybe a little bit about how do we actually get started. I have an IoT project. I have something I want to build, and I've done such a good job explaining and selling the language that you want to get started. So why don't you show us kind of what it's like and what the ecosystem looks like?
No, absolutely. Well, here. So before I screen share, so they're in Elixir, they have a framework called Nerves that basically you can kind of think of it like if you could imagine Ruby on Rails, like how Rails is such a wonderful framework. So imagine something like that, but for embedded devices written in Elixir, and they call it the Nerves project. So if you do want to get started with this, I'd recommend having some kind of little hardware. It's a Raspberry Pi Zero. I can kind of hold it up to the camera there. These are super cheap to get, but basically just any kind of little device that accepts a micro SD card. That'll make your life easiest if you want to get started. But let me see here. Let me get my screen pulled up. Yeah, there we go. So the NERVs framework has absolutely fantastic documentation. I don't want to get too in the weeds on the actual like NERVs development. So I think this would be the most beneficial for everyone just to kind of understand the general getting started. If you're new to Elixir, this is absolutely where you want to start because you gotta install everything that you need. It is important to note in these docs. So generally, anytime you work with any Elixir project, you do also have to have Erlang installed. So those two will come as a pair. In this case, though, specifically for NERVs, I'm on a Mac, so I install everything with Homebrew. They recommend installing things with Homebrew in the docs, but in this specific case, you need to uninstall the Elixir and Erlang versions that are automatically installed by Homebrew. And you do need to install with a package manager called ASDF. All of that is annotated in the docs, actually right about here. Yeah, that is their recommended installation. And there is, like, if you don't know, ASDF is basically a generic package manager for different versions of a programming language. And they have support for like any programming language. I use it for Node, I use it for Ruby, but it also works really great for Erlang and Elixir. So assuming you have all of that set up, so they have this really nifty project generator, and you can see it in the guide how to install it, but basically this command here, it's just mix nerves.new, which for anyone that's worked in a Elixir project before, or maybe initialized a Phoenix project, it's all the same stuff. So let's do mix nerves.new demo. Yeah. And also too, let me bump the font size on that. So we'll see here. So it's installing dependencies. That was actually pretty quick. So if we cd into the directory, there is, by the way, I'm a big terminal guy. I don't really use integrated development environments unless I absolutely have to. Elixir is a wonderful language in that both it is good in command line and it is really good in IDEs. Because Tyler, I know you use IntelliJ for all of your Elixir dev. Yeah. Let's see here. So you do need to set, as it says here, when you set things up, you need to set the target of the type of device that you want to export for, which if I remember correctly, yeah, it's RPi0 is what I want. So I have this pulled up. There's readmes for each of the embedded devices that you might want to develop on. So this is the one that I showed on camera. So RPi0. Yeah. And then we do run big steps get again. Yeah. So it's fetching. You'll see here. So it fetched the appropriate things. There is, by the way, so it's worth noting the NERVs framework uses build root for its images. So to kind of give an idea of what it's doing here, it's creating like a flashable Linux image that all it does is boot into your Elixir project. It's
This is a
kind of
pretty
clever.
quite honest, and I can compress most everything that he's gone through for the last couple minutes. That if you don't care about the technical much, that into there is a robust framework for developers to just pick up and use that allows them to write Elixir code and create Elixir projects and deploy them onto many of the most common targets that the IoT industry would expect for embedded systems. So write software, flash it, put it onto your systems, test it. There is a proven framework. I can never do that for this language. So you're not going to be thrown to the wolves. Hey, I know how to write code, but I can't deploy onto IoT devices. There is a framework and a system in place for you. So
Yeah, that's a good way to put it. Well, I guess then I can sort of wrap up this demo, but basically, so the commands here, so it's mix firmware, which I have typed out here. So this is actually compiling the flashable firmware that would go onto the embedded device. It'll take just a moment for it. Yeah. And so now if I had a micro SD card reader, I won't actually run this command, but all you need to do is have your micro SD plugged in and you do mix burn and you specify the path of the SD. It will then burn that firmware that you just built to the SD card. And then you can plug it back into this micro or to Pi Zero rather. and it'll just work. You can plug it in, you can boot it, you can mess around with the GPIO pins. It is very, very easy to get started. So yeah, it's honestly, you'll probably spend more time trying to just set up a debugging environment if you actually want to work on or to fix your bugs and everything. Yeah, no, it is a really pleasant ecosystem. As someone who had worked in Elixir for years and years, especially with like the Phoenix framework, they took a lot of the same ideas, and it feels right when it comes to embedded systems. Yeah.
All right. So I think I'm glad that we got to go through and actually demonstrate, yes, it is possible. It's not entirely theory. Transition out of theory, maybe into some more advanced concepts and techniques. Yeah, for kind of what we touched on earlier, Elixir for scalable IoT solutions. That's kind of something that I know the language excels at. I think it's worth putting a little bit more time and some color onto. I think it would be good to go through, reductions in process scheduling. That's something that I definitely think isn't thought about a lot, but it's one of the things that Elixir excels in. So maybe you could tell us a little bit more about that.
So the whole reductions concept. So let's say you've got your device running. So the Elixir and Erlang VM, it has a bunch of very lightweight processes initially. So it's very highly concurrent environment. Sometimes though, those processes start doing a lot of work. So this might be like, let's say they're processing some really heavy data or something, and you start to see the CPU spike on it. So the VM is very good at determining which of those processes are taking up a lot of resources, and then it will properly quarantine them in such a way that, let's say you had some other lightweight processes that, I don't know, check an API every minute, or even if it's serving user traffic, because let's say it was like a web server or something crazy, it could still give appropriate resources to those other processes while still having the hefty one run. The hefty one just runs a little bit slower, but that's okay because you still have the overall uptime and serviceability of
Mhm.
anything that's trying to connect to it. So it's really wild. Like, not a lot of languages have that. I mean, a lot of languages are kind of bad at concurrency in general, but it is kind of amazing to watch for like any Elixir project. So if you really throw a workload at it, it will take up the entire CPU if you want it to, which is really cool from an efficiency standpoint. But then at the same time, it can still do that without starving all of the other little jobs that might be running in the background on that
Yeah, and
same
that's a really
project.
important concept, especially in IoT, because when he said hefty process, well, hefty could be something relatively basic when we're talking about a device with hardly any resources on memory and CPU capacity on it. So
Yeah.
you don't want to be in a situation where you built a system where the moment that it goes under a little bit of load, or even just a little bit of load that's more than it was spec for, that suddenly your ancillary processes stop working. That balance and that trust and the stability is really, valuable. It's from a business use case to be able to trust that that's going to hold up. It's a good segue actually to the memory stability as well, which is the other big feature.
Yes, it is. Yes, it is very memory stable. So that's an important thing too. So any process in Elixir has its own memory namespace. So it is not sharing memory with anybody else. This is actually really, really good for things like you don't really get memory leaks at all. The process is either running or it's not. And let's say you had a process with runaway memory. Well, if it crashes, then you're fine. And so, and it sounds bad to say let it crash, but that's actually a very common thing in Elixir. You want your processes to crash because that's how you get the most stability. The language is designed in such a way that it will restart all of those processes, whichever it deems necessary. So when you look at it from a memory perspective, you're golden because any misbehaving process, like it'll just get terminated, restarted, everything's good, you know?
And to keep the important thing to note about that is, again, that's out of the box behavior. That's the way this language is built from the ground up. And that was one of the things that really attracted me to this ecosystem. I found, at least in my career, I've I feel like I spend almost as much time writing code and building and designing systems to survive my failure cases than I do actually writing code for what the heck the system's supposed to be doing. I'm worrying more about how it breaks and how it fails than doing the important, meat and potatoes of what your system is supposed to be accomplishing. And so I found it exceptionally refreshing to work in an ecosystem where failure is expected and handled gracefully. I'm not spending all the time and effort stressing about that. And it's something extremely valuable that you don't really realize until you have it, especially when you lose it. You have to work another ecosystem. So definitely one of my favorite things about the language is that let it fail mentality, because failure is going to happen. It doesn't matter how well your system is built. At some point, an exception is going to occur. So
Yeah. And it's fair too, like, because so many different libraries and frameworks like really harness that. So you don't even have to think about it when you're working with it. Like I know Nerves is that way. It's got a supervision tree in there. Libraries that I've written before, it's using all the same stuff. So things can
yes.
crash and you don't have to worry. Yeah.
Well, one of the points you touched on earlier about the memory efficiency and the lightweight processes are really kind of the underpinnings of that point I made at the beginning about the concurrency. Like, what does that mean? Like, oh, yeah, I'm very good at concurrency. Well, what makes that possible within this language is the exceptionally lightweight processes. So basically, any individual process has an incredibly small amount of memory that's necessary to run those processes. Like Henry mentioned earlier, they are protected. They have their own dedicated memory. And this language is built for very, very robust and easy inter-process communication. So it's very simple and lightweight for different threads of computation to be able to exchange information with each other in a lightweight and very performant. All of these things are, characteristics that you want or desire in any kind of scalable system, but also in, memory constraining systems where you can't put, hundreds of gigabytes of RAM towards your project. We're talking about small systems with limited amounts of computational ability and memory availability. So the ability for it to run and on such little resources efficiently, maintain that stability and safety, and be able to handle resource constraints, all make them very, very good candidates for these types of projects. Kind of looping back to IoT, right? Those are all things that characteristics that you have to solve for whenever you're
Yeah.
planning and building these types of projects. And that's kind of one of my favorite pitches about the language in general, just as an advanced concept. Get more for less, right? You're going to get more performance with less hardware. And the scale, that rule of thumb really does apply at all the gradient or the scale of the system we're talking about, whether that be massive enterprise systems with hundreds of servers being linked together to handle workloads for massive enterprise applications, or all the way down to small embedded IoT devices that all need to work together, pool their information, and process that together. Its efficiency and the cost of running these systems with Elixir is generally far less than comparable languages. And so that's one of the the major selling points that I really feel helps get people excited about it and motivated to try to adopt the language, is trusting that the final product is going to scale, it's going to cost less, and like Henry said earlier, you're going to get you code for 8 virtual CPUs and 100 gigabytes of RAM. That system is going to use every drop of resources that you throw at it, and that's that comfort is nice to have. So it's definitely one of my favorite things.
Yeah, no, absolutely. It's funny too to see other languages try to like imitate that now, because I'm very convinced that like within Golang, like Kubernetes basically ripped off Elixir when it comes to the like proper process scheduling and everything and utilizing cores, and from a reliability standpoint too, being able to restart services and everything. I don't know. It's like I don't want to say Elixir has it all, but it's got a lot in it, which I mean it's utterly fascinating to me. It dawned on me while you're talking. If I remember correctly, I think Elixir processes initialize with 2 kilobytes of memory.
It's like two or four. It's
Yeah,
very, very small.
yeah. And so, like, yeah, when you think like in terms of a embedded device, like that's absolutely perfect. Obviously you can shove a lot more stuff in that process if you need, but for lightweight, just a little background, whatever. I mean, 2 kilobytes isn't bad. So cool. Yeah.
Well, for advanced concepts, I think we did touch on some of the higher points. Just one of the things that before we transition to other topics, it needs to be stated again. all of these advanced concepts, the language does an exceptional job of making them accessible to individuals, no matter what the skill level is. These things are all baked into to the core language, to the core libraries that are available. So you don't have to approach your, development process and make a concerted effort to like build this stuff out from scratch or to know that you need to be doing it. These are self-reinforcing. The existing libraries and tooling make it such that you get these benefits without being an expert. It doesn't hurt to be an expert. And, it's for certain, project types, you're definitely going to want somebody senior to, oversee it and execute, but you can, cross train, bring newer talent in and expect them to consume and use new libraries. And you're going to get far better initial results of prototyping than you would get.
No, that's fair. It's plus too, like any team that you bring in, like they're gonna love the language just from a syntax standpoint. Or I say that. I mean, there is the whole C family camp, I guess, that really likes curly braces, but yeah.
I can make everybody happy.
Fair.
And it's there for it. I believe it's on Stack Overflow's annual surveys, right? Elixir is consistently one of the most loved languages, top 3 at least. Can't remember the exact ranking, but it's definitely up there. It's in its own.
And it's been doing it like every year seemingly since. So what? Elixir 1.0 in 2014, I want to say. Yeah, when it finally became stable. Once developers started using it, it keeps ranking up there for being loved. So yeah, can't argue there. I love it too. Yeah.
All right. So we talked a bit about the advanced concepts. I think it's also useful for people who are entertaining it or looking to get into it to just talk about some of the common challenges and the solutions for those challenges that you might face. IoT projects specifically, one of the most common things to come up is I have built hardware, I have shipped hardware, and something needs to be changed about that hardware. So how to actually, post my updates? And luckily, there is an answer for that. The NERS ecosystem does have that capability. So I think, Henry, you did the deep dive on that. Why don't you tell us, what that process looks like, just so people have a little bit of confidence?
Yeah, let me get into that. So I can probably this actually be a good case for another screen share. Yeah, so it is kind of an obvious problem when you're doing embedded systems. So you've written your thing, you need to ship it, or rather, it's out in the wild. You need to ship an update for it. How do you do that? So the Nerves creators, they actually thought ahead on this. And so you have this actually really cool open source framework that allows you to manage your over-the-air firmware updates. So this is actually a thing that you run yourself on your own servers. And basically you just upload your firmware to it and then it can push it out to the devices. Yeah, it's right there in the docs. It connects via Phoenix channels. Like it's all done for you. You don't really have to.
The detailed complicated explanation of it. I think the critical thing is, yes, it exists and you don't have to write it. Install it, deploy it, use it. Don't waste your time, reinventing the wheel. It's one of the most common, problems with these sorts of projects. Yes, like we touched on earlier, the NERS framework is there and it has matured sufficiently such that you can, just pick this up, use it, and extend it. So, it's nice to know, at least have the confidence that pattern is there. Others people have used it before. So your teams won't be, trailblazing that scratch. They can walk a well-tread path.
It is worth mentioning too, they already handle all the security for it in Nerves Hub. So like you don't have to be writing that yourself. And really you don't want to be writing that yourself. So much easier to just let someone manage it for you. And there is too always, like on any software team, anytime if you pitch the idea of, hey, we're going to run an open source service and just self-host. So like thinking as like a CTO and you've got like dev teams under you, there will be at least one guy in each of those teams that will be so overjoyed to run a thing self-hosted, Like I don't know what it is about the war on SaaS, but there's certain people who just really don't want to have SaaS dev tools. They want to run everything themselves.
Well, actually, speaking of the CTO, the target audience, I did do some thinking about what are the common things or concerns that might come up when you're evaluating Elixir for your IoT project, right? So I figured I would ask and see what you had to think about that. So what are the easiest ways to actually get started learning, right? Let's just say we did a great job. We told you all these wonderful things. You're actually interested in adopting it. How do how do I get my dev team? How do I get my devs or acquire new devs to start building me some projects in Elixir?
Yeah. So I can say if you have any Ruby developers on the team, you've already won half the battle. So to kind of give a little context for Elixir, so the original author came from a Ruby background. He was actually the author of a very famous Ruby package called Devise. But basically, so Ruby concepts have kind of been woven into Elixir throughout its whole language design. So if you have developers that do like Ruby, that they're competent in Ruby, it'll feel just like home. It is, I guess, really the only real learning curve to it is getting more familiar with functional programming because Ruby's object oriented. But in a general sense, though, just from syntax, people will be happy. I know that was a big thing for me when I made the jump because I started in Ruby for all of my back end systems programming. It is funny too that we have the saying that Elixir is literally just Ruby but fast. And I think that's a good way to put it. But yeah, so I mean, there's a lot of Ruby code running out in the wild, a lot of firms that use it already. It's not hard to get started.
I think another point to make would be, just, yeah, I totally agree with the crunch Ruby does. Also, as we touched on this earlier, right? Elixir being one of the most loved languages, you have a pretty good metric that your programmers will be happy in this ecosystem as well. The data would seem to suggest that, right? If retention, quality of life, attracting and retaining good talent is something that's important to you, the ecosystem has demonstrated that it does make people happy, which will help with those metrics. I guess the other thing that we were thinking might be useful to answer would be what does the cost of implementing an Elixir compare for other systems, right? I have a lot of choices, and there's tons of programming languages out there. Why choose Elixir over the others, and what's it going to cost me to do so?
So I mean, we've touched on it many times over already, but really, once you have a deployed Elixir application, it's going to save you money compared to other languages in general. So when you think about things like what I mentioned with Golang and how they have to have Kubernetes to get all that real stability in there, Elixir already comes pre-baked with it. And when you think about like from a server utilization, you can use all the cores that you pay for. We found, at least in our production deployments with Elixir, you tend to prefer fewer virtual servers that have a higher number of cores on them. And so this always ends up being cheaper than having like dozens and dozens of 2-core nodes that, are kind of throwaway, and you're maxing them out. And it is the concurrency isn't as good, it seems like.
As the financial person for the company, I very much enjoyed seeing server bill go down and the amount of compute go up. So that was my favorite one was, wow, I'm actually, getting value out of what I'm paying for instead of staring at nodes that are idling with 20 to 60% of their capacity never being used, but we still pay for. So if you're, stare at your cloud bill, it frustrates you. And that's definitely one of the things that can help you with. So that costs go down, infrastructure costs go down. So
yeah. And it is worth remembering too that not that you want to run your services at 100% CPU utilization all the time, but you do know for those few nodes that you have that if you are maxing them out still with the Elixir and Erlang VM, it is properly process scheduling. So you're not starving your customers for traffic. If there are some of the lighter weight processes in all this, you will serve everybody that you need to in your API, which is just fascinating to me. But granted, yes, please don't run your systems at 100% utilization all the time. Well, I mean, so coming back to Erlang Elixir, the OTP, the entire supervision structure to be able to restart processes and everything, that is such a wildly powerful tool that just other languages don't seem to have for some reason. I've had weird situations, like there was once I was running a Kotlin web server that did like some GraphQL stuff, and it was reactive and everything. It would randomly just enter a zombie state where the thing was up, but it wasn't really up. It wasn't serving traffic. And so really the solution was, or at least the immediate fix was to just turn the server off, turn it back on. Suddenly everything's fixed again, the zombie process. I think it may have been like a memory thing or something, but yeah, it's just little things like that. You don't generally have those kinds of problems in Elixir. So, I mean, it is what it is. And then you've also got your other like single threaded kind of languages. I guess a good example, like Ruby, you kind of have to jump through a lot of hoops to get a lot of concurrency in Ruby. That's also too why Elixir is so wonderful. And when you consider it just fast Ruby, because it's really just a properly done concurrency model. But
And one of the other questions we had is, right in that same thread of thinking, how maintainable is my finished product? Same thing. So all those same points, all of those libraries, the stability, it all makes it more maintainable because we're not sitting there re-engineering our core fundamentals. The core fundamentals are there, and all we're focused on is the app code itself. Yeah, I mean that touches on most of our major Q&A pieces. I think that hopefully with all the things we've talked about today, I've gotten a good feel for the language, how it fits in with the overall IoT ecosystem, the pain points that it addresses. The language itself has a lot going for it. We really do hope that you more seriously consider it for these sorts of projects. We'd love to see the language grow, especially how much we love it. We've built our entire company around it. It's how much we believe in it. So, I mean, is there anything else you think would be worth touching on, Henry?
it's not a whole lot. I guess it is worth noting that the language, they consider it pretty much done. There's nothing crazy coming in the future. So, like, if you had been holding off on adopting Elixir, maybe you thought about it already, now's an excellent time to start because the language itself is more solidified than it's ever been.
Yep.
So,
We very much agree with that. The ecosystem matures, ready for the adoption, and we hope to see more of that. We hope that you guys enjoyed the discussion, the content. If you do, subscribe, like, comment. We'd love to speak with you more on the subject. If there's anything you said that interested you, feel free to drop us a line. Everyone has a great day.
yeah, cheers, y'all.
Cheers.